An amusement park ride is a large cylinder which can rotate. A person stands against the wall, and after the cylinder is rotating at a certain rate, the floor drops away. The person remains stuck in position against the wall like a fly. Which one of the following is the correct free body force diagram showing all the forces acting on the person? Person is this. And we know the second Newton's law, it says that the net vector sum of all forces is equal to ma. And if it is in equilibrium, acceleration is equal to 0, so the vector sum of all forces should be equal to 0. It means that all forces must be balanced in all directions. And since it is, and actually to move with constant speed is the same as to be stationary in general. So since it is stationary in vertical direction, or in general an object can be moving with constant speed, it will be the same as it would be stationary. So it means that forces must be balanced in vertical direction. So it's impossible to be like C or like dy, because you can see that there is unbalanced force downwards, and it implies that this object must go downwards with acceleration. So it's not C, not D. Forces must be balanced in vertical direction. And if we consider a horizontal direction, since it is moving in circular path, we know, and this F is ma and is equal to 0, it's for translational equilibrium, and actually it's in equilibrium in general. But if we say about horizontal direction, acceleration is not equal to 0, and actually it is not in equilibrium in horizontal direction. Why? Because since it is rotating, there is centripetal acceleration to the center, and hence there must be unbalanced force to the center. So forces are not balanced in horizontal direction, because there must be horizontal to the there must be centripetal acceleration to the center to rotate or to moving in a circle, and to the center, not to the center. And what force is it actually? And it's what is normal reaction. It's force that a wall exerts on the object, and it provides the net force. It's the only force, so it is the net force, and it is equal to the centripetal. The centripetal, it's actually the net force to the center. So it's B. B is correct. And that's all for this question.